Good morning, students! Welcome back to Mathematics 9 Valenzuela Live Streaming Class. It's nice to see you again. Before we start, make sure your self-learning module is open on week 4 page. You must also have your pen and notebook with you. Are you ready? Let's begin. Our today's lesson is about problem solving involving parallelograms, trapezoids, and kites. At the end of this session, you will be able to solve problems involving parallelograms, trapezoids, and kites. From our previous sessions, you learned about different properties for each type of quadrilaterals. Let us check if you really understood the said lesson. Our first activity is entitled, Who am I? You will identify what type of quadrilateral is described in each statement. You will be given 5 seconds to answer. You can type your answer in the chat box. Are you ready? Let's begin. Who am I? I am a quadrilateral whose two pairs of opposite sides are parallel and congruent. My consecutive angles are supplementary and my opposite angles are congruent. My diagonals bisect each other. Here now your answer. Time's up. The correct answer is parallelogram. Let's try statement number 2. Who am I? I am a parallelogram whose diagonals are congruent and all interior angles measure 90 degrees. Key in now your answer. Time's up. The correct answer is rectangle. Very good, students. Number 3. Who am I? I am a parallelogram whose diagonals are perpendicular and bisect my angles. All my sides are congruent. Key now your answer. Time's up. If you answer rhombus, then you are correct. Let's proceed to statement number 4. Who am I? I can be a rectangle or a rhombus. My diagonals are perpendicular and congruent. Key now your answer. Time's up. The correct answer is square. You are great. Next statement. Who am I? I am a quadrilateral with one pair of parallel sides and the two angles that are on the same leg are supplementary. Key now your answer. Time's up. The correct answer is trapezoid. Next statement. Who am I? I am a trapezoid whose non-parallel sides are congruent. Key now your answer. Time's up. The correct answer is isosceles trapezoid. Last statement. Who am I? I am a quadrilateral having two distinct pairs of congruent adjacent sides. Key now your answer. Time's up. The correct answer is kite. If you got 7 correct answers, you are now ready to learn our next lesson. In the previous lessons, aside from the types of quadrilaterals, you also learned the different properties for each type of quadrilateral. It is important that you remember those properties since they are very useful in solving problems involving parallelograms, trapezoids, and kites. Let's try example number 1. ABCD is a square. If BC is equal to 3x plus 14 and DC is equal to 5x minus 8, find the value of x. Since that the given quadrilateral is a square, and we all know that one of the characteristics of a square is all the sides are congruent. Therefore, we can say that BC is equal to DC. By substitution, we have now 3x plus 14 is equal to 5x minus 8. By SPE or subtraction property of equality, we have now 3x minus 5x is equal to negative 8 minus 14. Simplifying, we have negative 2x is equal to negative 22. By DPE or division property of equality, we have x is equal to 11. Therefore, the value of x for problem number 1 is 11. Example number 2. Love is an isosceles trapezoid with bases LO and VE and median XY. If XY is equal to x plus 5 and LO plus VE is equal to 4x plus 6, find XY. To find median XY, we will use the formula in solving the median of a trapezoid, wherein median of trapezoid is equal to 1/2 times the quantity of base 1 plus base 2, or base 1 plus base 2 all over 2. So, by substitution, we have xy is equal to LO plus VE all over 2. Substitute the given value of xy and LO plus VE, we have x plus 5 is equal to 4x plus 6 all over 2. Multiply both sides by the LCD. We have now 2x plus 10 is equal to 4x plus 6. By SPE, we have 2x minus 4x is equal to 6 minus 10. Simplifying, we have negative 2x is equal to negative 4. Applying DPE, we have x is equal to 2. Since median xy is equal to x plus 5, substituting the value of x, we have xy is equal to 2 plus 5. Therefore, the measure of median xy is 7. Example number 3. EFGH is a kite. If angle E is equal to 95 degree and angle G is equal to 67 degree, find the measure of angle F and angle H. The given quadrilateral is a kite. According to the theorems on kites, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Given that angle E is equal to 95 degree and angle G is 67 degree, we can say that measurement of angle F is equal to the measurement of angle H. Let x be the measure of angle F and angle H. To solve for angle F and angle H, we add the four angles and equate to 360 degrees because the sum of the interior angles of a quadrilateral is equal to 360 degrees. Simplifying, we have 2x plus 162 is equal to 360. By SPE, we have 2x is equal to 198. By BPE, we have x is equal to 99. Therefore, the measure of angle F and angle H is equal to 99 degrees. Example number 4. A baker is making a 3-layer cake with the same thickness as the one in the picture. The top layer of the cake has a diameter of 8 inches, and the middle layer has a diameter of 14 inches. How long is the diameter of the bottom layer of the cake? The cake in an aerial view position is like this one. Suppose the cake is cut into two equal parts vertically. As you look at in a front view position, it looks like this. Given that the top layer of the cake has diameter of 8 inches and the middle layer of the cake has a diameter of 14 inches, let x be the measure of the diameter of the bottom layer. To solve this, we will use the property of the trapezoid that the measure of the median of a trapezoid is equal to 1/2 measure of the sum of the two bases. By substitution, we have 14 is equal to 8 plus x all over 2. Multiplying both sides by the LCD, we have 28 is equal to 8 plus x. Apply the SPE, we have 20 is equal to x. By symmetric property, we have x is equal to 20. Therefore, the length of the diameter of the bottom layer is 20 inches. Example number 5. The area of the kite made by Ralph and Renz is 196 square units. One of the diagonals is twice the length of the other diagonal. Find the length of each diagonal. In the given problem, the given area of a kite is 196 square units, and one of the diagonals is twice the length of the other diagonal. Let x be the measure of one of the diagonals or diagonal 1, and 2x is the measure of the other diagonal or diagonal 2. And the area is 196 square units. And to solve this, we will use the formula of area of a kite. Area of a kite is equal to 1/2 measure of the product of the two diagonals. And by substitution, we have 196 is equal to x times 2x all over 2. Let us use constellation method since there is a common factor between the numerator and the denominator. We have now 196 is equal to x squared. Simplify, we have square root of 196 is equal to square root of x squared. So, 14 is equal to x. Since diagonal 1 is equal to x, therefore, diagonal 1 is equal to 14. And diagonal 2 is equal to 2x, therefore, diagonal 2 is equal to 28. So, The length of each diagonal is 14 units and 28 units. Example number 6. A rectangular garden is 2.5 times longer than its width. It has a perimeter of 168 feet. What is the length and width of the garden? One of the characteristics of a rectangle is that opposite sides are congruent. The perimeter is the sum of the measure of all sides. If we get the perimeter of a rectangle, we have perimeter is equal to 2L plus 2W. Going back to the problem, the given are the length of a rectangle garden is 2.5 times longer than its width, and perimeter is 168 feet. We will use the formula of the perimeter of a rectangle. Let x be the width and let 2.5x be the length, and perimeter is 168 feet. By substitution, we have 168 is equal to 2 times 2.5x plus 2 times x. Simplifying, we have 168 is equal to 5x plus 2x. Combined similar terms, we have 168 is equal to 7x. By DPE, we have 24 is equal to x. Therefore, the width is equal to 24 feet. And the length is equal to 60 feet. I hope you understand our lesson today. To sum up our lesson, we learned that in order to solve problems involving parallelograms, trapezoids, and kites, simply apply the different properties for each type of quadrilateral. You can now ask questions. Is there a technique or an easy way of solving word problems? I know that some of you find it very difficult to solve word problems. The only key to solve word problems is to understand the problem. If you have to read it over and over again, please do that. Once you figured out the problem, the solution will be simple for you. If you have questions that comes to your mind, you can ask your math teachers during your follow-up discussion. For your home learning task, please answer the following problem. I hope to learn something from our discussion. Some words to ponder. Negative thoughts about word problems can be barriers to success. When we feel we have no control and continue repeating negative thoughts, we set up barriers to success. We need to calm our fears and change our negative feelings when it comes to word problems. A positive attitude is a big step toward success. Keep safe, everyone, and see you in our next session.